All right, today we're going to be solving exponential equations. So first, we're going to use the property of exponents to simplify each side of the equation. So guys, I'm going to look at number 4 because number 4 looks more complicated. Notice all of these have the same base. All the bases are the same. They're all 10. So that means we can combine the exponents. Now guys, let me just remind you real quick because we remember the properties. What if I had x squared times x to the 3? What does this equal to?
X to the 5.
Yes, x to the 5. We added the exponents, didn't we?
Yeah.
Okay, because this is x times 3 more x's. Total, there's 5 x's being multiplied. So we add the exponents. Notice here, the bases are both x. We're going to apply the same principle to number 4. The bases are both 10. That means we can add the exponents. So guys, this will be 10. And what will the power be if we add -4 and 9? Good. Now, same thing here, guys. The bases are both 10. That means we can combine these exponents. So what is v and 2v?
3.
And 4 and a -11.
-7.
Yes, there we go. Okay, so now I have a single exponent on both sides. So guys, my bases are the same. So we're just going to equal the exponents to each other and solve. So I have 5 equals 3v minus 7. Add 7 to both sides. We get 12 equals 3v. So v is 4. And that's your answer. You can always plug this in and make sure that this side will indeed equal this side. Okay, so guys, this was type 1 where the equations have the same base, okay? Now let's do type 2 where your bases are not the same, okay? So let's go to this side. Notice my bases are not the same here. Here, let's do number 6. Okay, so my base here is a 2, but the base here is an 8. So how should I rewrite the 8 so that the base is 2? Yes, 2 to the power of 3. Because 2 times 2 is 4, times another 2 is 8. So that's 3 2s. So this is how we're going to rewrite number 6 so that the bases match. Instead of writing 8, we changed it to 2 cubed. Okay, now that the bases are the same, we'll just equal the exponents to each other. So that's p minus 7 equals 3. So what is p? 10. Okay, let's do number 7. I need to remind you of an exponent rule. Guys, when I have 7 to the -1, how can this be rewritten? 1 over 7, okay? So guys, let's make this 1 over 7, 7 to the -1. This side can just stay the same. Okay, so we have to recall this. We have to recall the rule. If you have x to a negative exponent, you can write this as 1 over the same thing, but make the exponent positive. Okay, this is the rule. Okay, so now guys, my bases are the same. So your bases are the same. Just equal your exponents to each other and solve it. So what would the answer be? Yep, -3. 4x equals -12, so x is -3. Perfect. Okay, I'm going to pause here and let's look for a more difficult one. Okay, so let's look at a more complicated one like this. Before we get started, I'm just going to make a table real quick for 2's. What is 2 to the power of 2? 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. Good, and 2 to the power of 6 is 64. Okay, so notice I get 16, 8, and 32 right here, here, and here by doing different powers of 2, or base 2 with different powers. Okay, so let's rewrite these as bases 2. So to rewrite the 16, I need 2. The exponent stays the same. What do I need to raise the 2 to get 16? 4. So I'm going to put a 4 right there. Okay, so we rewrote the 16. Now it's base 2. I'll just put that in parentheses. Okay, now 1 over 8. How do I rewrite this 8 so that it's base 2?
2 to the power of
3.
3.
Good, okay. Now let's rewrite the 32. This will stay the same. We're just going to change the 32. 2 to the power of 5, yes. Okay, now we all have base 2. Now let's get rid of these fractions. How do I turn these fractions into, what do I do? Yes, so we can write this as 2 to the negative 3. Okay, this first one can just stay the same. 2 to the 4, negative 3y. 2 to the negative 5, and then 2y minus 3. Okay, so now we all have the same base. We all have the same base. Okay, so let's go ahead and simplify this using the properties of exponents, okay? Now, whenever you have, let me highlight this. Whenever you have a exponent raised to another exponent, what do you do? Yes, you multiply. You do not add, okay? Let me just do a little side note here. Whenever you add, it's when it's like x squared times an x to the 3. That's x to the 5. But if I have x squared to the power of 3, you multiply this. This is x to the 6, okay? So exponent to exponent, we multiply. So this will become 2 to the negative 12y. We multiply those two. This can stay the same, 2 to the negative 3. We multiplied these two. 4 times negative 3 is negative 12, and then you have a y there. I brought that next one down. This one, my base is 2. Negative 5 times 2y is negative 10y. Negative 5 times negative 3 is a positive 15. Okay, now we're going to combine. Let's combine. Remember, now we're going to do this one. Same base being multiplied. You add these together. I meant to highlight. Okay, so same rule here. We're going to add these together. So it'll be base 2 of negative 12y minus 3. This can just come down. We can combine these exponents. Okay, now we have base 2 and base 2. We just set the exponents equal to each other and solve. So we have negative 12y minus 3 equals negative 10y plus 15. So I can add 10y, get negative 2y. So y is negative 9.